Hello, continuation in our series of energy in the environment. We have discussed many sources of energy, and biomass is a clean source of fuel or energy, as we have already discussed in our previous lecture. Biomass can be converted into biogas. We have started the discussion already, and the production of biogas takes 15 days to complete. The solid waste formed as a byproduct is rich in nutrients and thus is used as manure. Sugarcane is a good source of biomass, and we have already said that the juice which is the solid thing which is left when juice out of sugarcane is squeezed out is called bagasse, and plants which are a storehouse of energy in which glucose is the basic energy unit of plants, and the electricity generation which can be carried out using biomass. Now, considering the biofuels which are being produced from biomass, biofuels are gaseous fuels which are obtained from biomass by the gasification process, and in this producer gas which is produced, which is a mixture of carbon monoxide, hydrogen, carbon dioxide, methane and nitrogen, is obtained by burning the biomass in a reduced supply of air at a temperature of 800 degrees centigrade. Water gas or syngas is obtained by burning biomass at 1600 degrees centigrade. It consists of carbon monoxide and hydrogen. Producer gas is used in the internal combustion engines. It can also be used to provide heat, which can be further used to produce electricity. Syngas, or also known as synthetic gas, has greater heating value than producer gas. It can be used for the synthesis of many chemical and fuels like methanol, biomethane and biodiesel using various catalysts. There is a picture depicting the production of biofuels from biomass. As we can see over here, the cattle dung which is processed, and ultimately the biomass which is formed, and through a series of productions biofuel is produced which is further used, and the waste product is used as manure. Two important biofuels which can be produced from biomass are biomethane and bioethanol, which are produced from sugar containing plants, and biodiesel which is from oil rich plants. Coming to the discussion of bioethanol, bioethanol is produced by the fermentation of glucose or sugar or starch. Here glucose is present as alpha glucose. The sugar from plants is fermented by yeast or bacteria to give ethanol. This is the reaction which is showing the production of alcohol from glucose. In this process, half of the molecular weight of glucose gets converted to carbon dioxide. The waste, which is also called bagasse, is used to generate heat, which can be further utilized for many other tasks. Since the stalks of plants, stalks means the stem of plants, are cut manually, so the crops have to be first burnt so that poisonous insects and sharp leaves can be removed. However, this causes pollution. This pollution can be avoided by the mechanized harvesting of crops. That means huge machines which are used to harvest crops instead of cutting the stalks manually. In the United States, bioethanol is made from starch based crops like corn, wherein glucose molecules are linked by glycosidic bonds which can be cleaved catalytically by enzymes, and this glucose is further fermented to give bioethanol. 10% of this is blended with gasoline. Bioethanol can be obtained from cellulose, which is a biopolymer of glucose containing beta glycosidic linkages. These linkages are resistant to cleavages, so a large amount of energy is provided by acids which are heated in pressure. However, catalytic degradation ways are being developed. A picture showing liquid biofuels from biomass. The biomass which is there, how it is helping to produce a liquid, the process which is shown for the production of liquid biofuels. In India, bioethanol is produced from sugarcane. When sugarcane juice is concentrated and cane sugar is extracted from it, the remaining liquid is called molasses. It still contains some sugar. This molasses is fermented, which gives bioethanol. And the picture is showing the concentrated, this black liquid, almost black liquid, is molasses, which is very concentrated form of sugarcane juice, and it contains a very small amount of sugar. Biodiesel. Biodiesel is a cleaner and a greener substitute of petroleum diesel. Biodiesel does not contain any sulfur or aromatics, and the emission content of unburnt hydrocarbons, carbon monoxide and particulate matter in biodiesel is much lower than petroleum diesel. Thus, biodiesel is mixed with petroleum diesel to reduce pollution due to emissions from vehicles. Countries like Germany are using pure biodiesel. The use of biodiesel, however, in India is much lesser because it is a comparatively expensive method. Biodiesel can be synthesized or obtained from vegetable oils. Biodiesel can be made from vegetable oils by trans-esterification process. This method involves stirring the cooking oil with methanol in the presence of potassium hydroxide as the catalyst. As a result, two products are formed, which are glycerol and methyl ester, which is the biodiesel. So, actually the composition of biodiesel is methyl ester and glycerol, and the reaction is shown as follows. So, this is the reaction which is showing us how biodiesel can be synthesized from triglycerides. Biodiesel can also be made from non-edible oils. This process is being researched in the CSIR Institute of Petroleum in Dehradun. And as you can see the picture of a plant which is Maduca indica. It is a non-edible plant and it is a very good source from which biodiesel can be manufactured. The research is underway using this plant. Biodiesel can also be synthesized from vegetable oils using a catalyst. Biodiesel from vegetable oils using catalysts such as glucose and sucrose has been produced by scientists in Japan. Partial anaerobic burning of sugar, starch or cellulose produces efficient catalysts for the production of biodiesel. The resultant product is then treated with sulfuric acid, which produces the catalyst in a solid state. Another source of biodiesel is algae. Algae contain 30 to 50% of their mass as oil in the form of triglycerides. This can be grown in wastewater. The greenish deposit on wastewater generally is algae. They grow faster than land crops and produce more oil. Pyrolysis of algae is carried out in closed bioreactors. Bio-oil is produced, which is further converted to biodiesel by the transesterification process. This is a picture which is showing blooming algae on water bodies. The left picture is an overview or a top picture, whereas the picture on the right shows a more microscopic picture of the algae. The distribution of non-renewable energy sources, what we are going to discuss now, and this is a pie chart which is showing the amount of renewable energy resources, nuclear energy resources, and certain other non-renewable energy resources which are or which presently can be used for the production of electricity. So, non-renewable energy resources are also known as conventional energy sources. These include coal, petroleum, and natural gas. These are called non-renewable energy sources because the formation of these takes thousands of years and thus cannot be replenished easily. Hence is the need to utilize the resources, especially the non-renewable resources, judiciously, and wastage of these resources needs to be minimized. Now, when we are considering non-renewable energy resources, in that the first and the foremost and the most common example which comes to our mind is coal. Tremendous amount of pressure and heat results in the formation of fossil fuels. Coal is a fossil fuel. It is derived from wood which has been buried in the earth's surface millions of years ago. There are 4 stages of coal formation, or are known as 4 forms of coal, which are, these are the 4 forms of coal, which is, as we can see in this diagram, peat, lignite, bituminous, and anthracite. These are the 4 types of 4 forms of coal, or a picture showing these forms of coal. The first one, the brownish one, is peat, then lignite, after that bituminous form, and anthracite. And these are all cyclic forms. That means from peat lignite is formed, from lignite bituminous is formed, and from bituminous anthracite is formed. Peat is a brown mass form of coal from which water is removed and the resulting solid is cut into blocks. The blocks are further allowed to dry. These dry blocks are then used as fuel. Lignite is also called brown coal. It is formed gradually from peat. Gradually means over a period of time. Lignite is a more solidified form of peat which is used for the production of electricity. That means peat is a softer solid of coal. Lignite is slightly harder, more solid than peat. Bituminous form of coal is formed when lignite is subjected to chemical changes and pressure. Bituminous form of coal is of two types further. Number 1, steam coal, and number 2, coking coal. Steam coal has a high heat value, so is used in steam boilers. Coking coal, on the other hand, on heating gives pure carbon called coke. Coke is used in manufacturing of iron. And another type, or the last type of coal, which is anthracite. It is the last stage of coal formation. Coal which is not extracted from the bituminous stage becomes hard. It burns with a blue flame. It is easy to handle, gives lesser amount of soot or the black particles on burning, and also burns for a longer time. Such type of coal is anthracite. There are many uses of coal, as coal can be used as a source of heat. It can be used as a raw material for chemical industries. Coal can be used as coke in iron and steel industry. Coke basically will be used as a reducing agent in the iron and steel industry. Coal gas, which is a byproduct obtained during conversion to coke, is used in gas stoves in kitchen and also for heating purposes. Coal tar and oils, also which are known as byproducts, are used to make dyes, perfumes, medicines, fertilizers, and also plastics. Coal gas is also used for the manufacture of synthetic rubber, and it is also used in the production of gasoline and certain other liquid fuels. Coal can be extracted by various methods, and to be precise, two methods which are employed generally to extract coal from coal mines include strip mining and underground mining. Both these processes are accompanied by their respective effects on the environment. That means the production of any source of energy which is necessary is always accompanied by effects, whether advantages or in terms of disadvantages on the environment also. In strip mining method of extraction of coal, strip mining is relatively easy and less expensive method, so is the preferred form of extraction of coal from its mines. In this picture, which is showing coal mines and the case or the example of strip mining, how is strip mining carried out. Whereas underground mining is carried out where half of the coal must stay in the mines to prevent them from collapsing. So therefore, underground mining of coal is comparatively less economical as compared to strip mining. And finally, considering the effects of coal mining on the environment, the disadvantages or the ill effects which it has, the polluting effects which it has on the environment. It causes removal of vegetation and topsoil, because for the extraction of coal, land has to be dug up, hence removal of vegetation and topsoil, as a result of which land turns barren. There is land collapse. Explosion and fire occurs because of underground mining, since it involves the blasting of the area at the site. Respiratory diseases among mine workers due to the inhalation of coal dust, and transportation of coal, which is done in trains, which has a great economical impact. So coal, which is a good fossil fuel, and it produces a lot of energy used for a variety of purposes, is extracted by various methods like strip mining and underground mining, but it has certain effects on the environment, due to which, although it has great advantages, but still, being a non-renewable resource of energy, its mining or its use needs to be restricted, and also because of its disadvantages or the effects which it is causing on the environment. And the electricity which is produced from coal is generally in thermal electric power plants, which are used for the generation of electricity. And this picture, which is showing the generation of electricity from the coals, look at the amount of smoke and the amount of pollution which it is causing in the atmosphere. So this is what we have discussed about one kind of non-renewable energy resource, which is coal, and its energy production, electricity production, and also discuss its disadvantages. We will continue this in our next lecture. Thank you.